Lesson 6-7, adding and subtracting measures of time. And in this lesson, you learn to add and subtract measures of time. When are you ever going to use this? You'll add and subtract measures of time when you're trying to determine how long a flight will last. Okay? So Demetria's school uses block scheduling. She has an A schedule and a B schedule. You will be doing this in high school, block scheduling. For example, she goes to math class every this week on Monday, Wednesday, and Friday. That's her A schedule. Next week she'll go to math class on Tuesday, on Thursday, and that's her B schedule. How much time will she spend in math class during the week when she only goes 2 days, and if each class is 1 hour and 30 minutes long? Okay, so to be able to answer this question, okay, we need to add and subtract measures of time. And in adding subtracting measures of time, the first step is to add and subtract the seconds. Okay, and the second step is to add and subtract the minutes. The third step is to add and subtract the hours. Okay, and finally we need to rewrite if necessary, rename, sorry, if necessary, in each step. We also need to remember that an hour is 60 minutes and a minute is 60 seconds. So let's take a look at Tuesday and Thursday. So on Tuesday she has 1 hour 30 minutes, and Thursday 1 hour 30 minutes. That gives her 2 hours and 60 minutes for math. Okay, since 2 hours 60 minutes equals 3 hours, Demetria spends 3 hours in math class during the weeks when she only goes 2 days. Okay, so when she only goes 2 days, Demetria spends 3 hours. Okay, so let's take a look at this example in aerospace. The countdown for the launching of this spacecraft was stopped at 12 hours 7 minutes 36 seconds before launch. Another stop occurred at 1 hour 28 minutes 10 seconds before launch. How far did the countdown progress between stops? Okay, so again, subtraction is necessary. Then let's estimate first. 12 hours minus 1 hour. We round it to 12 hours minus 1 hour. So it should be, our answer should be around 11 hours. And let's write it out. We have 12 hours 7 minutes 36 seconds minus 1 hour 28 minutes 10 seconds. If you notice, you can physically subtract 10 from 36. Okay, but the problem is you cannot subtract 28 minutes from 7 minutes. That is just impossible. Okay, since you cannot subtract 28 minutes from 7 minutes, you must rename 12 hours 17 minutes as 11 hours 67 minutes. How did this happen? You'll borrow 1 hour from 12 hours, and that's the reason why this became 11 hours. And the hour that you borrowed, you'll be adding to 7 minutes. Okay, so so that means if you convert 1 hour into minutes, it'll be 60 minutes, and that's the hour that you'll be adding to 7 minutes. And that's the reason why you have 11 hours and 67 minutes. Okay, so if you do that, okay, and rename 12 hours 7 minutes 36 seconds to be 11 hours 67 minutes and 36 seconds, we can now subtract. We can now subtract 28 minutes from 67 minutes, end up with 39 minutes, and 11 hours minus 1 hour will give you 10 hours. So the answer is 10 hours, 39 minutes, and 26 seconds. Very close to our estimate. Okay, so between the two stops, okay, there was a difference of 10 hours, 39 minutes, and 11 seconds. In example number 2, we are going to talk about elapsed time. Okay, and this is another aspect of adding and subtracting time. So let's talk about elapsed time. Elapsed time. Okay, so Josefina's flight is scheduled to leave Chicago at 11:14 a.m. and arrive in Houston at 1:36 p.m. How long will the lights last? So to be able to solve this problem, let's take a look at a clock. Okay, so to you need to answer this question, you need to find how much time has elapsed, okay, or has passed, and that's the reason for why it's called an elapsed time problem. And let's think of a clock. We know that a clock, okay, goes from 12 o'clock, and we start at 11:14 a.m. Okay, and you know that in the morning the clock will stop at 12 noon. So we go all the way to 12 noon, and we want to find out how much time has elapsed from 11:14 to 12 noon. And then from 12 noon, we want to find out how much time has elapsed from 12 noon to 1:36. So from here, we want to find out the time elapsed from 11:14 to 12 noon. Okay, and from 12 noon to 1:36 p.m. This is a.m. Okay, and that's what we want to find out. Okay, so 11:14 a.m. to 12 noon is 46 minutes. Okay, so we know that. And from 12 noon to 1:36, it is logically 1 hour and 36 minutes as well. So what we need to do is we simply need to add 46 minutes plus 1 hour and 36 minutes. Okay, or 1 hour and 82 minutes, and rename 82 minutes as 1 hour and 22 minutes. You end up with 2 hours and 22 minutes. So Josefina's flight will last 2 hours and 22 minutes. Before we go to example number 3, let's go back and revisit this, and let's explain this further. Okay, so we have 1 hour 36 minutes now. So this is good. That's 46 minutes, 12 hours. How do you know it's 46 minutes from this case? Because we simply do 12 noon, okay, which is 12 and 0 minutes, okay, minus 11 and 15 minutes. Okay, so if you notice, you cannot subtract 15 from nothing, so we borrow 1 from 12, and that becomes 11, and the hour that you borrowed, you will bring it down here. So you rename 12 hours, it becomes 11 hours and 60 minutes, and you know that 60 minus 15 will give you 46, and that will give you 0, 11 minus 11, and that's how you got 46 minutes. Okay, this is self-explanatory. How you got from 12 to 1:36 is 1 hour 36, and now let's add 1 hour 36 and 46 minutes. Okay, so we add this becomes 2, and this becomes 82. So that's 1 hour and 82 minutes, and you know that 82 minutes is not a real time, and you can simplify 82 minutes to be 1 hour and 22 minutes. Why? Because 82 there's an hour 60, there are 60 minutes to an hour, so 82 minutes is actually 1 hour and 22 minutes. And you simply add that to well, you don't add that because this is already your answer, so this simplifies to 1 hour and 22 minutes right there. Okay, you can actually write this so that you won't get confused. 1 hour and 36 minutes, okay, plus 46 minutes, and you get the same thing. All right, okay, let's do the last one. John Benoit of the United States won the first Women's Summer Olympic Games marathon. Okay, in 1984, her time was 2 hours 24 minutes and 52 seconds. In the 1996 Summer Games, okay, Summer Olympic Games, Fatuma Roba of Ethiopia won the marathon with a time of 2 hours 26 minutes and 5 seconds. How much faster was Benoit's time? So let's look at Roba's time, which is 2 hours 26 minutes and 5 seconds. And let's look at Benoit's time, which is 2 hours 24 minutes and 52 seconds. Remember the meaning of subtraction in this case, okay, finding the difference. Okay. Since you cannot subtract 52 seconds from 5 seconds, you must rename 26 minutes 5 seconds as 25 minutes and 65 seconds. So let's rename that. We have 2 hours, 26 minutes, and 5 seconds, renamed as 2 hours, 26 minutes, 25 minutes, and 65 seconds. Remember how we did this again. We borrowed one from 26, this became 25, and then we added 60 seconds to 5 seconds because that is the minute that you borrowed on 26. That's how this became 2 hours, 25 minutes, and 65 seconds. We want to subtract 2 hours, 24 minutes, and 52 seconds. Now we can subtract normally because 52 can be subtracted from 65. 25 minus 24 is 1, and 2 minus 2 is 0. So what happened is that Benoit, okay, ran the marathon 1 minute 13 seconds faster than Roba. Okay? And the word that we need to remember, secret word that you need to write down, would be Tom Brady. The name Tom Brady. Thank you for watching.